So as you can see onto your desktop, this workshop is all about PCB design workshop. So you can see already few of my samples that I had already attached onto the screen for the projects that I had worked earlier. So these are mostly for the clients, for my external clients, the project I had worked on. Some projects are my personal projects. And as you can see, these are all done inside Autodesk Fusion 360. So I use this software my most of the time. So uh, that's why I always recommend this software. So let's move on to the agenda for the today's workshop. So let's move on to our next slide. So here is the agenda for this today's workshop. As you can see, the first thing that we'll learn about the PCB enclosure design planning, like whenever you will get a project or if you are doing enclosure for your personal project, personal PCB, then how you can plan your design. What are the things you need to consider before starting designing your PCB enclosure? And the next agenda is definitely like how to design a 3D printable enclosure, because there are few terms we had to consider all the time when you are designing something for 3D printing, because whatever the things you are designing, that must be manufacturable, right? It must be designed for, I can say, DFM, design for manufacturing. And if we'll add this term DFAM, that is designed for additive manufacturing, so it's about 3D printing. So this is what we're going to learn today. What are the small considerations we had to take when designing such kind of things? So we'll talk about that. And then the last agenda will be like, what are the more learning resources that you can follow to get ahead into your skill that you are learning? Maybe it's 3D modeling or product design. So we'll talk about that as well. So let's move on to our next slide, guys. So as you can see, the first thing I always used to talk into all my events is like, why Fusion 360? Why we should use Fusion 360? There are lots of software you can try out as well, because if you will learn one of the software like Fusion 360 or any other software, you can get comfortable into any other software very easily, because once you are already aware of all the terms like 3D terms like extrude, cut, join, and all these features are almost similar in all the tools. If you are following your Autodesk tools, then it will be similar in all the Autodesk versions of the tools. Like the tool name will be same in the AutoCAD as well. It will be same in Fusion 360. It will be same in Autodesk Inventor as well. So most of the concept is all the time the concept is same. So just try to learn the concept. So as here you can see onto my screen right now, we'll talk about like why Fusion 360. And all the time I say that Fusion 360 is a cloud-based CAD CAM tool. So first thing, why I recommend this software, it's free for students and educators. The 1-year license you just need to activate from the Autodesk website, and you will get a complete access to the software without any hidden features or anything. And it's easy to install. It will just take half an hour to set up the complete software. You don't need a fancy hardware to run this software. You can even run this piece of software onto your normal laptop or PC. So that's why I always recommend this software. And here are few of the sample works that I did for some of my clients in the past, as you can see right now onto your screen. So these are some enclosure designs. Some are for 3D printing, some are for injection molding. So it's completely like what is our requirement, and based on that we can do the thing. Now, so I told you why Fusion 360. It's easy to learn also, since the community is very big. Now let's move on to our next slide, the most important slide, where you can download this software. So definitely you need to visit the Autodesk official website to download this software. And since it's a cloud-based software, you had to create your account like we used to do for the Dropbox or some other cloud-based tools. So you had to create your account onto the Autodesk official website. You need to sign up if you are coming on for the first time. But if you are already a user of Autodesk products, then definitely you need to log in using your email ID and password. Then once you will log in, you have to download a small piece of setup onto your PC, and that you can install it, and you will be ready to use Fusion 360. Just log in into the user interface of Fusion 360 and you are done. The tool will be ready for you to use. So this is how you can do. And if now let's move on to the next thing. Next thing is like, now let's learn about, like, I'm not going to talk about the Fusion 360 basics into this session, because I had already did lots of similar things that you will be able to find onto my YouTube channel, recorded contents. Just search for the term 3-dies on the YouTube and you will find my channel. There you can see we'll learn about like what are the steps we had to take while we are planning the PCB enclosure. So all the time I always recommend the steps are really very important. Planning is really very important. If you're not planned your content well, you will find lots of difficulty in getting the end result. So it's really very important. So as you can see, the first thing all the time when you are start designing your PCB enclosure is ask or arrange a PCB step file. I mean the PCB 3D file. As you can see, I already attached few samples onto the desktop. So these are the basic PCB for which we are going to develop an enclosure around that. So if you guys can see on the screen, if you can identify which kind of PCB is that, just comment in the chat box because it's a very famous PCB. It's a very famous development board. You can see onto your screen right now. Just comment in the chat box if you know the name. So you had to arrange for the 3D file for these PCBs, the step file, because the step file is the most common 3D file format, and it's very acceptable for all the. Joel is commenting that it's Arduino. No, Joel, yes, it's Arduino, but the Arduino is the second one. It's the R3, that is the next generation board. Yes, Mohan, it's Raspberry Pi. So it's Raspberry Pi 4B board, and whenever you are starting your enclosure design, the first thing that you had to ask for the step file for your PCB board, and that you can ask with your client. If your client will able to provide you, that's okay. Otherwise, if he or she will not be able to provide you, what you can do, you can also download those CAD models from the free digital libraries, free CAD model libraries, and there are lots of free CAD model libraries. For example, if we talk about the first one and the most famous one, it's a GrabCAD. So here you can see the GrabCAD library from where you can download almost any kind of 3D models. For example, let's say I'm searching for a board called MKS Gen L. Let's search for MKS Gen L and we'll press enter. And here you can see we are getting a board. Someone has created the complete 3D model for this MKS Gen L board. And if I will just open it, here you can see we already got this step file over here. Here you can see. So what I had to do is I need to download this step file. But in this case, in our case, what I'm going to do is since we are not going to create an enclosure for this board, we are going to create enclosure for Raspberry Pi. So what we can do, or we'll create an enclosure for Arduino Uno R3 board. That's the recent development board from the Arduino company. It's a very famous development board, and it's most common between IoT engineers and the person who are doing robotics and all those stuff. So we'll try to find this board. So we'll just go on to the GrabCAD library and we'll go on to the library. Here you can see it's library, and on the search term over here, we'll just write for Arduino Uno. Here you can see I'm just writing Arduino Uno, and here you can see this is the board that I was talking about. It's Arduino Uno R4. Sorry, it's Arduino Uno R4. So I will just click on it, and here you can see we can download all the files. And if I will say look for the content, you can see there is the image file and the step file. These two are inside the complete zip file that we're going to download. Also, if you want to check the board details, you can go on to the 3D viewer. You can click on the load in 3D viewer, and you will be able to see your board, like how someone has developed this board. So this is the board that we're going to take, and we're going to design the enclosure for this one. So we'll just go back, or we can click on this download file, and I need to log in to download onto the anything from the GrabCAD community. It's free, and here you can see it's getting downloaded, right? We'll go on to the download folder, right? We'll make a right click, go on to the show in folder, and what I'm going to do now is I'm going to keep that that step file that we had just downloaded onto my desktop. So I will go onto my desktop and we'll paste that. So it just got pasted. Let me show you where it just got pasted. Yes, here it is. Here you can see this is the step file we had just downloaded. Now, as you can see, if your client has not provided the step file, you can also download the file if you have the details of your board. Like if you know the name, you can search onto the different digital libraries on the internet. If it's available for free, it's fine. Otherwise, if it's not available, you can ask with the client. All the PCB designing softwares like KiCad or Altem 3D, they are all able to export any PCB design into a step 3D file. So it's possible. So you just need to ask with your client and ask them to export your PCB design into a step file and send it to me. And from there, I can start designing the enclosure. So that is the first step. I had already downloaded the 3D file from the GrabCAD. Now the next step is to import that file that we had just downloaded into Fusion 360. So now let's bring Fusion 360 onto our screen. There you can see this is my Fusion 360 screen. And if I will go on to home view and we're going to start onto the right project folder. So if you want to learn the basics of Fusion 360, I will strongly recommend you to go and check out my YouTube channel. There you will find lots of basics videos. From there, you can just get started with the user interface of this software. And so let's move on to Fusion 360 workshop folder. And here you can see what I will do. I will create a new folder and will give it a name. Here you can see I'm just giving it a name with the same development board name, and I had pressed enter to create this folder. I will just go on to this folder now. We'll click on the upload and we'll select the file, and the file is onto our desktop. Here you can see our R4 desktop, the R4 file that we had just downloaded, and we'll just upload into our Fusion 360. So you can see it's a 7 MB file, and I will just click on this upload icon over here, and it is just getting uploaded. So we'll move back onto Fusion 360, and here you can see it says the upload is in progress. It is going to take few seconds, guys, since I told you it's a cloud-based software. So everything that you are uploading onto this software is getting uploaded to the internet space, internet storage. So it is definitely going to take some few seconds time based on your internet connection. So it's my case, it is going to take few minutes, few seconds, but in your case, it may be quicker also. It completely depends upon your internet connection, since this software needs internet connection to upload any kind of thing. So here you can see it just got uploaded. Sorry, the upload has just got finished. Here you can see. Now the next thing that we're going to do is whenever you will launch Fusion 360, by default there will be always a default design file open onto your screen. As you can see right now, this is the name is right now untitled. So we are going to give it a name. So we'll just click on this save icon over here and we'll give it a name. Let's give it a name like enclosure. Here you can see I had just written enclosure, and it's getting saved onto the location Fusion 360 workshop or R4 folder. So the location is also correct. I will just click on the save, and the moment I will click on the save, here you can see it's just got renamed, right? File name just got renamed and a new file just got created over here, right? It is open right now, as you can see. So let me know, guys, if you guys can hear me. I can see there is some small internet connection problem onto my computer. So just comment in the chat box if you can hear me clearly. I'm just waiting for your feedback, guys. Just comment in the chat box if you can hear me, all of you. Yes, that's great. Okay, so as you can see right now, thank you, Vargab, Satya, Jopal, thank you, Mohan, thank you, Joel, Cadron, thank you so much. Thank you, that's great. There was a small glitch onto my internet. So here you can see we had just uploaded the R4 file, and we had also created our first design file. So now we are almost ready to start designing the 3D printable enclosure, right? And if I will move on to my presentation folder here, you can see that we had finished 2 steps. We had arranged PCB file, we had imported into Fusion 360. Now, next thing, all the time, whenever you are designing, planning your enclosure, clarify all the ports and openings to be provided. For example, let's say you had an enclosure, right? Let me open an enclosure design for this. Let's say you had this enclosure, right? The top and bottom piece. And whenever you will enclose any PCB inside an enclosure, definitely you had to have some opening for all ports, right? Maybe you had to connect a charger, you had to connect some kind of internet ports, you had to connect some kind of other ports, or maybe storage device. So you had to provide some openings onto the face of the enclosures, right? So that you had also had to decide. So also let's take one of the questions from the chat box. Jopal is asking, was it was it a SolidWorks file that you had downloaded from the GrabPad? No, Jopal, it's not a SolidWorks file. It's a open source file. We can say that a step file is an open source file that we can almost open in any of the other CAD software. It's a kind of open source file, I said you. So step file is we can open in any of the CAD software, right? Now, so I was talking about the openings. So these openings you had to decide. So that's why I had written into this step, like clarify all the ports and openings to be provided. And this can be decided by your client, like for whom you are designing this enclosure, for the board for which you are designing this enclosure. For example, if I will just open this board, let me just open this board onto my design space. And guys, if you feel that this workshop in this session, if you are learning something, just comment L in the chat box. So here you can see, just comment L in the chat box. I'm just waiting for your answer. If you are learning something into this workshop, because I'm trying my best to make all my workshop like as much information I can provide for you. Absolutely. Thank you so much. So here you can see this PCB board has few ports already, like for this charger or a power port, power source port. Then the type C kind of connection over here. Then some switch over here. So definitely whenever you were designing an enclosure, we had to assess few of the things, like we had to have this reset switch from outside. We'll be able to insert any kind of type sleeve plug into this port. We'll able to plug any kind of power source onto this port. So we have to take care of the those openings as well. So if you are doing a personal project, you can decide those openings. But if you are doing it for someone else, like for your client, you can ask with them, like, what are the openings I need to consider before starting the project? Because once you are done with the enclosure, it's really it's a little bit harder to make any changes in the between, right, in the middle also. But if the requirement is there, like you have to make the changes, that's completely fine. But if the things are clear prior to starting the project, that's a very good thing. So that you can take care of, clarify all the ports and openings to be provided. Now, apart from this, the next step is also clarify all the add-on components needs to be added onto this added onto your board. For example, let's say you have designed an enclosure and you had designed a completely tight fit enclosure for this PCB board, and let's say client wants to add a fan on inside enclosure. So since you had not provided any space on over here, how it's possible? So that's why I always recommend to clarify for all the add-on components, clarify for all the add-on components that needs to be used in with this PCB board. So whenever you are designing an enclosure, you are taking a small space for that also, whatever it is. So these are the steps that you had to consider before starting the design, right? Now let's move on to the next step. Now let's design the enclosure file. So there are two different, I had divided my enclosure file into two different categories. Here you can see it's one kind of enclosure is like two-part enclosure, where one is the top part and the other is bottom part, and where we can attach both the parts using this screw based system. Here you can see these four holes for the screws, and from the bottom we can put some maybe kind of threaded insert, or we can use kind of bolts also. So that way we can attach both the parts together to fit the PCB board inside this. Whereas the other thing is like snap fit enclosure, where we have completely 100% 3D printable parts. So you can see these small snap fit. Here you can see this small snap fit things. So how it will work, like you just need to apply some pressure onto the top and bottom part, and it will be get snap fitted with each other. So you don't need screws, you don't need threaded insert to do such kind of enclosures. So two different kind of enclosures, but in our design, in our consideration for this Arduino board, we are going to use the screw based enclosure. But you can also try out and try to learn how to design the snap fit enclosures, because whenever you are designing snap fit enclosures, most of the time, so snap fit enclosures are like you have to consider lots of stuff, like your 3D printer tolerance and what materials you are going to take for 3D printing. So those are the steps you have to consider before starting designing your enclosure. But in case of screw based enclosure, you don't need to consider those things. Maybe a small little bit of tolerance is enough to get your enclosure fit with each other completely. So those things will take about in the design session. So let's move on to designing those stuff. So here you can see we'll go move on to the enclosure file, and the first thing that we're going to do right now is we are going to use one more component over here. So that will use from the Fusion 360. So don't worry, we'll go on to the data panel, and what I'm going to do is I will close this enclosure file. So here you can see our enclosure file is open right now. So I'm going to take this UNO R4 Wi-Fi board that we had just uploaded into Fusion 360, and we are going to attach this board into this enclosure file. Since here you can see both are different files. So I will just make a right click and we'll click on the insert into current design. So the moment I will click on the insert into current design, this enclosure will get attached into the enclosure file. Here you can see. And here you can see it is just attached. This small chain I can say is that this enclosure board design is just attached into this file. It's not already into this file. The image is just visible onto this enclosure view one file. So we'll go into the top view from using view cube. Here you can see like this. We are into top view. We'll turn on the origin. Like here you can see, here is my origin, and we'll orbit it little bit like this. And I just want to reorient it in the home position. So here you can see I will just rotate this using 90 degree, using this. Here you can see using this what I will say, whatever it is, but we can grab this and rotate it and adjust it position in space. There you can see. Now the position here you can see it's the origin is somewhere over here. So what I will do, I will just go on to the top view. I will make sure that it's on the center, something like this. So it's not perfectly centered, but we'll just try to keep near to center, something like that. And then I will go on to the side view also, and we'll check that it's oriented correctly, and we'll move it a little bit towards the top as well, and we'll press OK. Here you can see we had just imported this UNO R4 file into our enclosure file. Now we'll start designing the enclosure. So for that, what we'll do, we'll turn off the origin, and the first thing that we're going to do is we're going to create a rectangular base for this complete board. And before that, I also want to keep a fan over here onto this space that you can see over here. So we're going to use the, let's say we're going to use a 2020 12-volt small fan. So there are a big library inside Fusion 360, pre-built library that we can simply import into our Fusion 360 design. So that is why this is also one of the reason I like Fusion 360 so much. So just go onto the insert panel over here, and here you can see it's called Mac Master Car Component. So just open that. And inside over here, you can download all the pre-built library of the models. You can download a step file that you can use as a reference onto your designs. So I will search for the DC fan. There you can see DC fans. And when I will search for the DC fan, it is giving me lots of options. So I will just look for the metric ones. And I just want to use a smaller fan. The smallest fan possible is 38 mm, right? This is the most smallest fan, as you can see. And if I will just check, so we are maybe it's not the right product. We'll search again, DC fan, and I will click on this one. Then I will download this square fans. Then the overall height is definitely, I just want to keep the minimum possible, maybe 25 mm, the smallest fan. And then I will just drag it towards the right, and we'll click on this part number over here. There you can see. And here you can see I can download the step file, that particular model. So it's standard. So if you will try to order this component from the Mac Master Car component, you will get the same dimension component. So I will just download it, and we'll use that into our model. So here you can see we just got downloaded. We'll go into the top view, and we'll make sure that this model is also in the right orientation. So we had to rotate it a little bit, maybe by 90 degrees, something like this. And we'll move it towards top. We'll go into the top view. We'll orient it onto the right orientation. Maybe I want to keep this fan onto this location. There you can see. We'll go into the side view. We'll make sure that it's not touching any other components. So we'll move it a little bit towards the top. As you can see, now it's clear. So maybe this will be the location of my fan whenever we are planning this enclosure. And we'll click on this capture position. And here you can see we have just imported this fan. So whenever we will design the enclosure, we'll design it like the base. On the bottom part, this enclosure will be fixed, whereas on the top part, we'll be going to fix this fan, and we'll also going to consider the opening for this fan onto the top part, right? So let's now move on to designing the enclosure. So the first thing that we're going to do is, and all the time, guys, if you got any questions, if you are thinking that I'm going fast, you can just comment in the chat box. You can comment in the chat box, and you can ask your question. You can ask me to go slow. I will try to do that. So just comment in the chat box if you have any confusions. So the first thing that I'm going to do is I will create offset plane from the base plane. So I will just click on this offset plane, will select the base plane of my enclosure design, and will create an offset. So it is not touching onto these pins. There you can see I'm just getting a 5 mm of offset, or maybe a little bit more, maybe 8 mm, and we'll press OK. So you can see I just created a new plane with reference to this face. There you can see this is 8 mm bottom from the bottom reference face. Now I will just click on that particular plane that we had just created, and we'll click on the create sketch. Here you can see now we are into sketch mode, and we can start tracing the edge for this particular design. So for that, what I will do, I will go into the create panel over here. We'll activate the project tool. So project tool is like convert entities if you are using SolidWorks. So it's similar tool. It's called project tool inside Fusion 360. So I will just activate that, and will select the edges of my board. Here you can see I will try to select the every edge of my PCB board. Here you can see. So we'll get the exact shape of my board. That you can see. So I had selected all the edges of my board, and will press OK. And the moment I will press OK, here you can see all that sketch just got traced. So if I will just turn off my board file, here you can see this is the sketch we got, right? This is the sketch we got, and it's completely referenced with our board file. So now the next thing is like we'll use the offset tool. We'll select the complete profile. We had to select the every pieces. Sometimes it will select automatically the complete chain, but if it is not selecting automatically, what you can do, you can manually also, you can just select all the edges that you want to offset. And this time I just want to offset it. I want to make it 2.6 millimeter. Here you can see 2.6 millimeter. So why I am considering 2.6 millimeters, since I am designing this for 3D printing, I'm going to explain. I will explain you those in the between. Let's make it 2.8. I think 2.8 is best. And then since I had created a new offset of 2.8, then again activate the offset tool, and this time just create a offset of 0.2 millimeter. So here you can see. And this time just create an offset of 0.2 millimeter. So it's going towards outside, right? So I will just press OK. Here you can see. Now what I will do, just click on the finish the sketch. We'll move it like this. We'll turn on my board, and here you can see. So this is what we had created so far, right? And as you can see on the bottom, we had created the plane 8 millimeter away from the bottom face. So that we can also change at all the time. Here you can see, if you'll just go on to the design history at the bottom of Fusion 360 page, like if you want to change anything, just give me a second, guys. I'm just checking, like if someone else wants to join onto this event. Just a second. Yeah. So as you can see, we had created this plane 8 millimeter offset from the bottom face. So all the time, if you want to adjust this distance, for example, in this case, I am thinking that I am feeling that this distance is a little bit higher. So what I can do, I can go on to my design history, and this is the tool that we had performed to create this offset plane. So I can just make a right click on the edit feature, and here you can see it says 8 millimeter, that we can just change this to 6 millimeter, or maybe yeah, 6 millimeter is good. So I will just press OK. So you can see the distance just got updated with new distance, that is 6 millimeter. So this way you can quickly do the thing, right? Then someone is asking in the chat box, like the sketch you have drawn, is it on the XY plane? So it's not on the XY plane, Joe Paul. I told you that we had created a new plane, that is this new construction plane. As you can see, this LO plane, that is referenced with the bottom face of this PCB board. And whereas if I will just turn on the origin, so here you can see the default XY planes are over here. Here you can see this, the default XY planes that we are not using at this moment, because the board that we had just imported into this design is not completely centered with this design file. So that is nothing to do with this origin file. So you can just start all thing that you have to consider is that the plane has to be flat. That's the most important thing. So here my plane is flat, so I had just created the sketch over there. Now if I will just turn off the plane, and here you can see we had just created two offsets that we had projected the sketch for the outer face of my board, and we had created two offset. The one is 0.2 millimeter and the other is 2.8 millimeter, right? Now I will just click on I had clicked on the finish the sketch. Now I will activate my extrude tool and we'll select the complete base first. We'll make sure that we had selected the complete profile, and we'll give it a base first. Like we'll want to keep a base of maybe 1.6 millimeter or maybe 2 millimeter. Here you can see the base thickness is 2 millimeter. I will press OK. So this is the base we had created, and the moment we had created the base, as you can see, the sketch just got hidden. So we'll go on to the sketch folder. We'll turn on my sketch back again. Here you can see. Now again, I will activate the extrude thing and will select this profile. There you can see, not the, here we got three different profiles. One is the inside one, other is the this one that is 0.2 millimeter offset, and the other was 2.8 millimeter offset. So we're going to select this offset one, and we're going to create a height like this. Here you can see. Now if you go on to the top view, you can see we got space over here, right? We got clearance. So that's why I had created this 0.2 millimeter of offset over here, just to make some clearance with the walls of my PCB board. So the things will completely fit inside this complete setup. Here you can see. And now I will just make sure that I'm going up to the fan top face. So I will just click on the fan top face, something like this, right? Or what I can do at this moment, I can select the complete profile. Let's select the complete profile. Let's make a solid thing, and then we can sell it also from the inside. That's the other way. So let's do that. Let's just delete the bottom. Okay, activate your extrude tool, select all the profile like this, and then just extrude it towards the top. We'll make sure that we are first touching the top face of my fan, and then we'll add few millimeters of distance, maybe +4. Here you can see. So maybe it's not -4. Here you can see we have just added those distance, and here we'll make sure that it's working as the new body. So here you can see everything is just getting enclosed inside my space, right? Now what I will do, since the fan area we had to subtract it from there, so we'll go into the top view. We'll change the view to maybe shaded with hidden edges. So here you can see we can see our fan. So what I can do right now is I will create a sketch. We'll click on the top face of our enclosure to create a sketch, and we'll make sure that we are only taking a space for the fan, just to use some less material onto our enclosure file. So that is what I'm trying to do. So we'll dimension this sketch that we had created, maybe 25. Let's make it 30. And from this direction also, let's make it 25 or maybe 24. I think will be good. Here you can see, and we'll click on the finish sketch. Here you can. Now what I will do, I will subtract these areas. I don't want to unnecessarily use material, so I will just subtract these areas up to this phase, and we'll make it 11, something like this. We press OK. There you can see this is what we got. Now I will just change the visual style to shaded with visual edges again. Here you can see. So this is what we got. Now we're going to apply some chamfer over here. So we'll select these two corners. We'll apply a chamfer of 11 millimeters. Here you can see, and we'll press OK. So this is what we had created, and it is looking some kind of weird, but once you will progress, you will be able to see the results, and you will find that it's good, right? So you can see this is what we had created so far. Now what I will do, I will turn off the two components, and we'll go on to we'll turn off the sketch also. We'll go on to the modify panel and we'll activate this tool called cell. So we had activated this tool called cell. We'll go on to the bodies and we'll select the body. So here you can see the body just got selected, right? And now I just want to keep an inside thickness of 2.6 millimeters. So I will just give it an inside thickness of 2.6 and we'll press OK. So the complete enclosure just got hollowed. So I will show you the section analysis. Here you can see, right? It's hollow from inside. So now we're going to split this complete enclosure into two different parts. So for that, we'll go on to this modify panel and we'll click on the split body. So before activating this split body, we'll need a plane along which I want to split my complete enclosure. So for that, I will activate my offset plane tool. We'll select the face that I want to offset and we'll give it an offset of 2.4 millimeters. Here you can see, or maybe 2 millimeters. There you can see we are just giving an offset of 2 millimeter and we'll press OK. So we have just created a new plane that is offset from this face by 2 millimeters. Now we'll go on to the modify panel. We'll click on the split body. Then we'll select the body that I want to split. Then we'll select the splitting plane. And here you can see it's giving me a preview that it will split this complete body into two different parts. One is the top part and the other is the bottom part. And we'll press OK. Here you can see. Now if I'll just turn off the body 2, you can see this is my body 1. And if I will turn on my body 1, here you can see we had to maybe bring down this plane little bit by a small distance. So we'll go on to the design history and we'll click on the edit feature. We'll make it 2.4 or maybe 2.8. Let's just edit this one and write 2.8 and we'll press OK. So here it is. So this is the bottom part, guys, and this is the top part. So we had created two-part enclosure and it's looking good, right? Now, as you can see, it's looking very great. Now, what I can do, if I will just turn on both the files, here you can see at the bottom, we had this enclosure file sitting, and at the top we got the fan sitting over here. So on the top, definitely over here, we had to create some air ventilation openings for the fan. So for that, we can create that. We'll just click on this create a sketch. We'll click on this face, and here you can see if I will just change the visual style to shaded with hidden edges, there you can see we'll able to see my fan. So we had to create air ventilation opening around my fans. So for that, what I can do, there are multiple ways you can do that. So in this case, what I will do, I will just create a rectangle first, something like this, a simple rectangle. There you can see I will just dimension this simple rectangle. So I'm just trying to match the shape of my fan. That is what I'm trying to do. So I'll just activate my constraint tool. We'll make sure that this point and this line is touching, and also on this direction, this point and this line is touching, and also on this direction, this point and this line is touching. So I'm just constraining my the rectangle that we had created with respect to the fan shape. That is my aim. Now, if I will just create a small rectangle onto the corner, let's say if we'll define the size of this rectangle. Okay, let me do it again. Something like this. Then we'll define the size of this rectangle, maybe 3 millimeter by if I will apply the equal constraint between these two edges, the other also became 3. Now, if I will check the size of this one is 25, so we'll pattern this complete thing by using the rectangular pattern. We'll select this rectangle. We'll select the direction. In this direction, I just want to keep 6 number of times, and the distance I don't just want to keep 25 or maybe 22. There you can see, and on the other side as well, I just want to keep 6 and 22, right? So I will just write 6 and minus 22. So here you can see I had created a pattern of rectangles over here, and we'll press OK. And we'll just click on the finish sketch. We'll change the visual style to back to shaded with visible edges, and then we'll activate my extrude tool. We'll select all these things and we'll drag it towards bottom to make a cut, maybe by minus 3 millimeter, and it will make a cut. So here you can see, okay, so I did it wrong. had to select these profiles, tangle profile. I'm really sorry I selected the other one because we will select those ones, will not be able to get supports. So we had to select this profile just for the air inlet vents. There you can see these all are air inlet vents. This is small rectangle. And if I will press OK, so this is what we got. So we got air inlet vents for the fan as well. So this is what we got. Now let's move on to the basic. Now, if I will turn on the body, there you can see on this face, if I will just see, we got two different openings for the ports, one for this type C port and one for this power module port, right? So we had to take consideration for those. And also here you can see, we got some problems over here. The things are like something, here you can see the things are like intersecting with the body, so that's not right. So we had to provide some more clearance at this position. So we'll just go on to my this sketch that we had just created, and we had to make it maybe 9 mm, and we'll press OK. And now we'll try to see if we got some. We had to change this one also to 9 mm, the chamfers just that we had created earlier. So we'll just write it 9. We'll press OK. There you can see now we got clearance, right? Now it's not colliding. So that way you can quickly make changes to onto your design using design history inside Fusion 360. That's the good thing. But all you need to do is do lots of practice, make lots of model inside Fusion 360. So we'll get more comfortable in using this software. And once you will get more comfortable, you can quickly make changes. And whenever you are designing anything for 3D printing, there is no mean what software you are using to get the end result, because at the end what clients need is they need the HTML file for 3D printing. So they will not care about like if you are using SolidWorks, if you are using Inventor, if you are using UGNX. So they will just care about like if you will be able to provide HTML files or not. So that's the most important thing. So just master any of the tool that is accessible to you, available to you, and just expand your skills around that. So you can see we just got the bottom view, and in this phase we need two openings. So for that I will activate my create a sketch tool, will select this phase, and will again change my visual style to shaded with hidden edges. So we'll able to see these shapes onto this face, right? Now what I will do, I will just project these profiles. So for that, what I will do, I will just turn off the body, will select project these edges onto that particular face. Here I can see these 4 edges, and for the type C port, again, I need to project this complete face. Here you can see this is not right. This is not selecting as a single face, but still if we got some time, right, we can easily select all the faces one by one also. So we just want to make it accurate. That's our first aim. So I had selected everything and we'll press OK. And the moment I will press OK, we'll get the sketch projected onto our face. And now if I will just turn on the body, and we'll also turn off, change the visual style back to shaded with visual edges only. So you can see we got two different shapes. So what I will do now, I will just offset these things. And here I will just offset it by maybe 1.2 millimeter or maybe 1.4 millimeter, something like that. Yes, that's completely fine. And we'll press OK. And we will also offset these profiles over here. Let's offset, make unselect the chain selection, then select one by one all the edges that you want to offset. Okay, let's select again. Okay, it's not selecting, guys. So maybe there will be a small gap that I cannot see. So what I can do, I can create a rectangle over here, something like this, and then I can just constrain it with respect to these points quickly. Here you can see. And then I can offset these ones, because for the type C port, there is always offset needed, maybe of 2 millimeter, because not 2 millimeter, maybe 1.4 millimeter. Here you can see, or maybe 1.8 millimeter, because whenever you will see your type C charging plugs, those are already having some extra material onto the tip of your charging plugs. So for that, we are going to add some extra space around my type C port. so my charging plug will able to go inside. So these are the small consideration all the time you have to keep in your mind, like if you're going to use any plug, whether it is going to fit onto this area or not. Because if you will 3D print and if you will find that these are not fitting, your complete print will get wasted. So just make sure that you are making the right approach. Now I will just press OK. So here you can see this is what we had created, and we'll click on the finish sketch. And then what I will do, I will activate my extrude tool. I will select these profiles because I want to make a cut, right? So I have to select all these profiles. Since these are all separate profiles, so I have to select one by one. I don't want to miss any one of them. So I will select one by one. Here you can see, I just need to select every smaller profiles. Here you can see. Now we had selected all the profile. What I will do, I will just turn off this enclosure board files and will drag it towards like this and will make it minus 2.6. We press OK. So you can see we had made a cut over here for the ports. And if we'll turn on my board, here you can see these are the two ports that we want to access from outside. So the cut is completely fine. Here you can see we can plug in any charger or anything over here from on the top, and here we can plug any type C ports or type C charger from over here. And this is not looking very rectangular, so what I can do, I can just corner these fillet these corners also, so the things will look more kind of organic. So I will just apply some fillet, maybe of 2 millimeters, something like this, or maybe a little bit higher, guys, maybe 4 millimeter or something like this. And we'll press OK. Here you can. So this is the shape we got for the top and bottom. And if I will just turn off the, let's just rename these things also, so things will be more clear to us. So to avoid confusion, so I will just write this one as top, and we'll write this one as bottom. Here you can see. So here are my top and bottom. So if I turn off the top, here you can see these are the two ports that we wanted to access from the inside. And also there is a small port on this direction. Here you can see this small port. Here some connectors will come. So for that also we had to take a small consideration. So we'll go into this phase, we'll activate the sketch. And again, I will change my visual style with the hidden edges. Here you can see. So this is the small port that we wanted to consider. So we'll turn off the body. We'll project the edges for this particular thing. Here you can see. And we'll press OK. We'll turn back it again on, and we'll turn off this visual style to visible edges. And now I will create a rectangle from this corner to here, and we'll make sure that it's constrained with this thing. And now I will offset this complete sketch that we had created for this port. Again, I want to keep some space for the port. So I will just write minus 1.6. There again. So this distance, this offset that I am considering at all the point is because you have to check the opposite connector that is going to connect onto this particular port. So just consider that connector, whatever the size of that connector. So for example, let's say we had the type C port, right? So what you can do, you can just go onto the internet and you can look for the type C specification. If you will search for the type C specification, so, and if you go onto the images, you will be able to find lots of drawings and design where you will be able to get the size details. And from there, you can collect the data and you can try to use those data onto your enclosure design. So here you can see the things that will fit onto this type C enclosure. There is always some plastic material around that. So we have to take those consideration also, like if this part is going to fit onto this place, we had to make an opening bigger with related to this opening, this size. So that is what I'm trying to do. That is what I am trying to consider. So that's why I had created this opening this much bigger. So whenever we are going to plug any type C kind of cable onto over here, so we will get extra access, so the things will fit correctly. So that is what I am trying to do. Now for this one, the same thing, like if you're going to fit any kind of connector over here, so that's why we had considered some extra space for this connector. That I don't know what is the male plug that is going to fit over here, but we had already considered some extra material around that. So That's why if things is coming over here, it will fit correctly. Otherwise, if you want to make it perfectly correct, so all the time ask for the connector names with your clients as well. So just mark these connectors onto the board file. Just mark on it onto your board file and send that those snapshots to your client and ask with them like what kind of connector is this. Just give me the name, and from that I will just search on the internet and I will get the specification like what are the sizes I need to consider, right? So these are the three connectors that we had to access from inside for this particular board, these two connectors and these things. So I think the connector part is done. So the next thing is that we also had to make a small hole for this switch, because if you will just see from the top, we'll need a small hole from there. If I want to reset my board, I can just insert any kind of sharp object and I will be able to reset it. So on this top face, what I'm going to do is I will create a new sketch. Again, I will turn on, I want to see my board. So here you can see this is my thing. So I will just create a small circular hole around this, right? I will click on I will just define the size of this one first. So let's say it's 4.2. I will click on the finish and we'll come on to this direction. We'll make a small hole like this. There you can see. Cut. There you can see we got to see that particular button from the top. And now if I want to reset this board, I can just insert any kind of a screw or anything, screw or maybe screwdrivers or anything. We can just use those things and we can reset our board from the top. So you don't need to open your enclosure all the time to access that particular button, access that particular switch, right? So guys, any questions up to this point? All the time, if you have any questions, just comment in the chat box. And also, I don't know whether I am recording this session or not. Let me just check. Oh, it's already recording by default. So Jopal is asking, how do you project the geometry of a body that you would like to sketch? Could you please report? So it's really easy, Jopal. So I will just explain you again. For example, let's say if you want to project any profile from your board onto this top face. So it's really easy. First thing, just select the face, activate the sketch. So that plane is just ready to create a sketch. Now turn off the top body. Now you will be able to see your board only. Now let's say I want to project these small profiles onto that face. So just activate your project tool. Then just select the features that you want to project. Let's say I want to project this one and these circles. Here you can see these circles, right? And if I will press OK, so here you can see those profiles from the board just got projected onto the top face or on the face that I had selected where I wanted to project. So it's really easy. It's really easy. It's like I told you, it's like convert tool in, if you had used SolidWorks, there is a tool called convert entities. The similar way the project tool works inside Fusion 360. And if you have not used any of the tools, simply just come on to it and check it out, right? In Fusion 360, follow the same process. So just go back. Here you can see. Now, the next thing, guys, since we had created lots of stuff, next thing is definitely like how you will make sure that these two pieces will fit together. Like this, how you will make sure that these two pieces will be placed together, either screw or snap fit. So that we're going to do now. So if I will just turn off the top, here you can see what we can do. If you want to make a screw fit, we had to make a screw spaces onto the corners. But as you can see right now, we had made this box, we had made this enclosure completely fit with my board. Like there is no extra space we had kept around my board. So it's really hard to take the arrangements for the screws inside. But if you'll see, we can make arrangements outside as well. So that is what we're going to do now. So just turn off the top. We'll click on this face and we'll click on the create sketch. Now, what I will do, I will create 4 circles like this. Here you can see 4 circles, simple 4 circles, and we'll make sure that if I will select all the 4 circles by pressing shift on my keyboard and will apply the equal constraint, all 4 became equal, right? And we'll also make sure that these 2 circles on the same horizontal orientation. So we'll apply the horizontal constraint and these 2 circles also on the same horizontal orientation. So I will just select both the origins for both the circles, will apply the constraint. Now if we try to move this one, here you can see the other one is also moving because the constraint is applied, right? We'll do the same for these two, same vertical orientation, and these two, same vertical orientation, like this. Now I will make sure that the circles are touching to this edge, so we'll apply this tangent constraint, right? We'll do the same on the other side. Boom, here you can see. Now we'll make sure that since we are going to create a hole for the M3 screws, so we're going to keep a 3 millimeter of hole, there you can see. And now if I will just offset it by 2 millimeter, 2.4 millimeter, sorry, something like this. Here you can see 2.4 millimeter. We'll do the same offset repeat on all the dimensions. So for that, what I will do, I will just hover over to the offset dimension, and you can see that it says D35. So that is the number that we're going to use for the other offsets. So we'll just select the offset, and instead of giving the dimension, we can write D35. And so that way, all four offsets that I'm creating will just get connected with each other. D35, and here also D35. There you can see, right? And we'll move it a little bit towards inside. We'll define it from this side. From this side, this distance, let's say I want to keep 10 millimeter. And on the other side also, from this side, let's say I want to keep 12 millimeter, something like this. Now I will just click on the finish sketch. We'll activate my extrude tool and we'll extrude these portions, let's say by 6 millimeter, or maybe minus 10 millimeter. Okay. Instead of cut, I will make join. There you can see. So this is the phase arrangement that we had created for the screws. So the top and bottom will fit with each other. And what I will do, I will fillet these corners also. I just don't want to, I want them to look more organic with the shape that we had created, with the enclosure that we had created. I just want them to look more beautiful. So I will just select all the four corners. I will give it a fillet of maybe 2 millimeters. So here you can see. Now it is looking more kind of fused with the enclosure file. And because we had provided fillets over here, we had added some extra material on the corners. So like whenever you are tightening your screws with the top and bottom, so that will add some extra strength with the walls also. And also since we're going to 3D print it, so we are going to apply some chamfers onto the bottom edges, right? So we'll just select the bottom edges and we're going to apply some chamfer of maybe 45-degree angle. So we'll just give it some chamfer distance onto the bottom, and we'll give it maybe, let's say how much it is able to make, maybe 3 millimeter, not working 2.5, it's working 2.6. So in this case, if you're not sure how much it is going to work, so you can just consider, right? Here I'm considering 2.95. So now, as you can see, the things are not instant overhang, right? If we are going to print this enclosure in this orientation, we got some 45-degree angle over here. So that way, what it will happen, it is not going to print like a rough material. Since we got some over 45-degree angle over here, so we got some support for 3D printing. So this is also optimized. I will say this design is optimized for 3D printing. Now, if I will just turn on the top part, again, I will turn on our old sketch that we had created. Here you can see, and the same that we're going to use for the top as well. So we'll just activate my extrude tool. We'll select all the profiles that we had created for the bottom, and we'll extrude it up to the top face. We'll make sure that we are joining, and we'll press OK. Here you can see. Now what I will do, I will just turn off that sketch we had created. We'll activate my fillet tool. We'll select all the four corners. Really easy, just select all the four corners. Here you can see, I'm just selecting all the four corners, and we'll give it a fillet of 2 millimeter that we had already given it for the bottom. So here you can see, this is what we had created, right? And here you can see we got a small problem. I don't know whether you can notice it or not, but we got a small problem onto this enclosure. So guys, the small problem that I can see is this one. Here you can see this hole that we had created for the screws are really close to the wall of my enclosure. And the problem will be like whenever you will try to tighten your screw, there is always a head onto your screw, right? And that head will maybe colliding with this wall. So whenever you are considering these holes, try to make little bit offset from the wall, maybe 1 millimeter offset from the wall. In this case, what we did, we had just made it tangent with the wall. If you will just see the sketch, old sketch, we had just made these circles tangent with the wall. But what I will suggest you to make it a little bit offset with the wall. So that's the good practice, right? So now here you can see this is what we had created, and it's completely 3D printable, that you can 3D print and try to see if it's fitting your components inside or not. Now, apart from this, there are few more things left. Since we are running out of the time, maybe I will just suggest you and you can try to make it by yourself. So the two that more things that left is like, if I will just turn off the bottom, here you can see this enclosure is just sitting onto this place, but we have not created anything. So this PCB board is fit with this enclosure. So for that, what you can do, you can make some mountings, the base mountings. For example, if I will just turn on the enclosure file, here you can create some standoffs for your enclosures. For example, if you can see this design, let me just show you some design. Yeah, here you can see, if you will just see this design, here you can see this is called standoff. So on the top of this standoff, if you will place your PCB file, you can just screw your PCB with the base of your enclosure file. So that way it will be fixed with the base. So that thing you can also try, to create into your Fusion 360 design. But here, since we are running out of time, you just need to project all the 4 holes for the PCB board that you can see, this 1, 2, 3, and 4. These 4 holes are already being provided onto your PCB board, just to make sure that you will be able to fix your PCB board with the bottom of your enclosure file. And you can also do the same for the fan also. If you'll just move on to the top face, here you can see on the fan also we got 4 different holes, and for the 4 different holes you can create 4 different mountings. So for that, maybe we have to delete these corner holes, and on that place we can use 4 mountings for my fan also. So from there we can just place any screw and we can mount it with the top of this enclosure of your PCB board. So that way you can do. And now let's apply some appearance onto this enclosure. Let's say I want to make some apply good appearance. Let's say some plastic. Let's search for the plastic called blue plastic or something. So Fusion has some already had some material libraries. So just go on to the modify panel option over here, activate the appearance, and here you can see it's called appearance window that you can see right now on your screen. So just go on to the appearance window and search for the color that you want to apply, or search for the material. Like let's say I want to apply plastic. So you can see we got different kinds of plastics. So let's say yellow plastic. So I will just drag it and apply it onto the top of my enclosure. So since it's not downloaded, so I will just click on the download option over here. So material will just get downloaded onto my Fusion 360, and now I can just drag it and apply onto my bodies. And let's say apply some different plastic on the bottom like this. Here you can see. So this is what we had created. Enclosure that is completely 3D printable inside Autodesk Fusion 360. And now if I want to let me just take a small screenshot. So whenever I will be sharing recording with all of you, so you will be able to see yourself. Or I'm also creating a small kind of post onto my LinkedIn about this session. So here you can see this is the enclosure that we had just created. And what I will do, I will select the top part and we'll try to move it little bit towards the top like this. Here you can see, and we'll press OK, and the bottom also will move it little bit towards the bottom like this. Here you can see, we'll press OK and we'll turn on all the components. So you can see this is what it is looking right now, my enclosure file, my enclosure design file with all the details, right? So this is what we got, guys. So let me know if you got any questions. And also I'm going to take a snapshot with all of you attending this session. So I just want to encourage more people to come and join this kind of workshops. And so I will be able to refine my content little bit more. So here it is. So I had just saved it, guys. And this was all about, guys. I told you it's all about Fusion 360. I explained you. Now let's move on to our presentation part, and let's move on to our slide. Now the next slide is definitely we had learned about how to design the enclosure inside Fusion 360, and our next slide is definitely what are the learning resources. So this is the most important part. I told you you can watch YouTube, you can search for my channel. Apart from that, I'm already hosting a free Udemy course onto my Udemy channel, so you can also check it. If you will just go onto the Udemy and search for Fusion 360, here you can see is that just search for the Fusion 360. And if you will search for the Fusion 360 on the Udemy platform, and if you will just go onto the prices and we'll change that to free, like free courses available on the, and here you can see just a second, guys. Yeah, so if you'll just go on to and search for the free courses available, here you can you just go on to the free courses available. You will be able to find my courses. So I will just change that to English. And here you can see this is the course that we had created, and I'm giving it this for free onto my Udemy channel, Udemy platform. So just go and check it out. This course called Design for 3D Printing with Autodesk Fusion 360, and enroll onto this course, because for very limited time I had made this course for free onto my Udemy channel. And I had also pasted the link onto the video onto the chat right now. If you want to enroll it right now, just enroll it, because maybe in few days this course will get become to paid course. So right now it's completely free. You can enroll it. You can have lifetime access to this course, and whenever you feel comfortable, you can start learning with my Udemy course. Now let's move back to our presentation file. You can also check out my Academy channel, that is academy.3dash.com, and learn more about my contents. So now let's move on to like who I am. So if you are following me on LinkedIn, so guys, I'm a full-time freelance CAD designer and also 3D printing enthusiast, and I also work as a trainer where I used to train my industry professionals, students about AutoCAD, SolidWorks, and Fusion 360. So those who want personalized training can reach out to me. I can help with them on also. So this was all about this session, guys. Thank you so much for joining.